So this is the task that we are going to do as we have discussed last time. It's SAP2000 that we're going to discuss. It's a world famous structural analysis software where you can use for pretty much any analysis. As I told you, there are several parts in structural engineering. There is analysis and there is design. Okay, even though both these things are possible with SAP2000, we don't normally recommend design. We do this for analysis for the time being. If you are very confident and if you know exactly to the pinpoint accuracy what you are doing, you can use that for design. But as I told you, we don't normally trust a result given by a software package. We have to check that. That's why we do the analysis, we check it, and we do the design manually. Okay, so we are going to discuss this case. It's a 5-story building that you're going to, this is a project-based thing. It's a 5-story building that you're going to discuss. Okay, roof is a terrace to make things simpler. So this is an office space. So as I have told you, you have to have some knowledge in the load applications. What is the imposed load that you use for office buildings and all to follow this course. So I give you time. So I'm expecting you to have a decent knowledge on that to go with this. Okay. And these are the steps that you're following. This we discussed last time as well, but I'll go through briefly. So first thing, we have to define the units that we're using. Normally, we are using kilonewtons, meters or millimeters, let's say meters, and centigrades. If we use thermal loads, for the time being, we are not using thermal loads, but in any case, we are defining all three units together. So we are having these 3 units to be defined. Then defining initial geometry, there are several options. We can go with blank. What I'm recommending at the moment for the case that we are designing is we are going for grid only. For this case, right? These are all for this case. Okay. Then we are going to define the grids. Then we are going to add structural elements, especially columns, beams, and slabs. Columns, beams, and slabs. Okay. Here there are 2 steps. We have to define the sections. Then we have to assign the sections. So this is the point up to which I'm planning to go with you all today, right? If we have like if it takes too long, we'll stop halfway through. But for the time being, these are the steps that I am planning to cover with you all for the time being. Okay. If you come up to this point, that means you are pretty confident in SAP2000. You can do pretty much any you can handle any case that is given. Okay, so let's go into the software. So this is a software. I'm just opening that, so you get this window normally, right? You can read these things, and when I press next, there are different tips that you can follow. Okay, there are different tips that you can follow. You can go through them, but for the time being, we'll be stuck with this. So this is a window that we are having. Okay, there's this menu bar, file. You can start a new model. You can open a model. You can import. Those are the options. You can go through them leisurely, right? There are these 3 buttons that are there are these 3 buttons that are active at the moment because we don't have a model here at the moment, right? We start with creating a new model. You start with creating a new model. Okay. So there are different options. There are different options. So here the first thing, defining units. Defining units. That's what we are going to do. Here you have this option. In case if you forget to do this, at the bottom right corner, you have that option here. Okay. Here, let's say we are going with kilonewtons, meters, and centigrade that I have marked earlier. This is the first step. So you have selected the units. This is very important, whether you are adding meters or millimeters or maybe newtons or kilonewton, that makes a huge difference. If you're going for CGS units, the values that you add in CGS units, you'll not get accurate results unless you use CGS units here, right? So you have to be very particular on this. You have to be very confident on the unit that you use. So we are selecting the unit here, okay? Here you have various options. These are templates. These are templates. If you select this blank option, you can do any of these things. You can do any of these things from the blank. Here, you'll be given a grid. That place you'll be given a grid. Beam, there are these options. For the time being, for this case, we'll be going with this grid only option because we have a well-defined grid here. We have a well-defined grid here. Okay, we'll go with this grid only option. Remember, if you need a beam to be analyzed, you can go for this option. If you need a truss to be analyzed, you can go for this option. Right? If you need a truss, you can define the grid and do the truss as well. If you want a truss, you can go for the blank and do the truss as well. There's no hard and fast rule. Right? You can do anything, you can feel free. For the time being, it's easier for us for a case like this to go with this grid only option. So I'm clicking this grid only option. There are several options that you need to enter. Here we have two tabs: Cartesian grid lines and cylindrical grid lines. Okay. See, here you have X, Y, and Z, right? The typical Cartesian coordinate system. Here you have R, theta, and Z. These are polar coordinates. If you have a circular building, you may be able to go with this. Okay. So how from the center, from how many meters I have in the first grid, and what is the angle from the zero axis. It is cylindrical. For the time being, what we need is a Cartesian coordinate system. Okay. Here we have three things to be entered. The three things to enter: number of grid lines, grid spacing, first grid line location. Number of grids in X direction, number of grids in Y direction, number of grids in Z direction. Grid spacing in X direction, grid spacing in Y direction, grid spacing in Z direction. Okay, so we need to enter this. So I'll mark X and Y in the presentation. So you have this grid. This is what we are going to define. So for the time being, we'll select this to be our X line and this to be our Y line. Okay, Z will come from the paper towards us upwards. Okay, so in X direction, how many grid lines do we have? Let's say this is 1, 2, 3, 4, 5. Number of grids in X direction, because this is our X direction. Number of grids in X direction is 5. Number of grids in Y direction, 1, 2, 3, 4, 5. That's also 5. Connection is slow, so there will be a lag. Okay, so number of grids in x direction is 5. Number of grids in y direction is also 5. Right? Number of grids in z direction, what we normally do is we model one flow and we copy it. In SAP we call it replicating, not copying. Okay, copying is also there. Copying is for different thing. So if you want to create a flow and copy to for other flows, that's called replicating. Okay, so in x direction we have 5 grids, y direction we have 5 grids, in z direction we are modeling 2 grids, the ground and the first floor level. That's one flow. Okay, so number of grids in x direction is number of grids in x direction is 5. Number of grids in y direction is 5. Number of grids in z direction is 2. Okay, grid spacing. Grid spacing in x direction. Grid spacing in y direction. Grid spacing in z direction. We need those details as well. In x direction, that is in this direction, what is the grid spacing? Here you have 3 meters. Here you have 2.5 and 2.5 grids. So it's easier for us to define the grid to be 2.5 and make that one adjustment, one exception of these 3 meters. Okay. Initially, we define the grid to be equally spaced in 2.5 meters. There's just one exemption of these 3 meters. We can modify that. So grid spacing in x direction is 2.5. Grid spacing in y direction, it's 3. No issue on that. Grid spacing in z direction is the flow to flow height. We'll take that to be 3 for the time being. Okay. So we have most of the details that we need. So we'll go to the software now. Number of grids in x direction we know, number of grids in y direction we know, number of grids in z direction we know, and grid spacing in all these directions we know. Okay. Now we know these things. Number of grids in x direction is 5. Number of grids in y direction is 5. Number of grids in z direction, we are modeling one for, it's 2. It's the number of grids in each of these directions. Grid spacing in x direction, as I can remember, was 2.5. Y direction, it was 3. Z direction, it was 3. Okay. So first grid line location, we'll take 0, 0, 0. No issue on that. We need this to be modified if you are modeling 2 buildings on the same model. 2 buildings on the same model. Okay. Now we have the grid system defined. Okay. So you can press the scroll and drag, that's panning. You can rotate the scroll, that is zooming. Those are typical things. Here we have 2 windows. Here we have 2 windows. Left side, it says XY plane at Z equals 3. It is XY plane. You remember the grid that we have defined? This was X. This was Y. So it is this plane, XY plane at Z equals 3 level, first floor level, right? So if we take here, you can see a red dot. Okay, the same dot appears here. So if we go here, it's the same location as this. Okay, but if you go here, there's nothing shown on the left hand side window. Why? Because we are in the floor below. This particular point in the floor below, if you want to see that, you need to go to the xy plane and z equals 0. You press this window, from this arrow you can go down. Then if you take here, you can see the red color dot at that particular location, right? You can see this grid at that particular location. Okay, so if you want to see some other planes, let's say it's z plane, it is that plane. You can see a light blue color rectangle. So whatever is shown here is displayed there. So if you take here, it's that point on that 3D grid. So you can move like this to each of these grids. If you want to make modifications to one particular grid, you can move with that. This arrow goes the other way around. Okay, hope it's clear. So if you want to go to the other plane, you can see this light blue color rectangle. You can move with these arrows. So there are two windows. It's an easy interface. If you want 4 windows, you can get 4 windows, X, Y, Y, Z. Some people prefer that. Some people prefer that. If you can go to these options, windows, if you select 4, there are 4 windows. You can select XY here, XZ here, and YZ here, and 3D here. Okay. By default, what we are used to is this. This is easier, this is larger, like that. Okay. Now we have defined the grid. There's one modification that we had to make. Here it was 3, but we have defined it to be 2.5. Okay. When I take the cursor, you can see this place, the position that we are in is shown. Here this is 0, 0, 0, that is 0, 0, 3. That's also an indication. That is 0, 3, 3, like this. Right. Now we need to make that modification. From here to here, what we have defined is 2.5. The actual size is 3. So we have to make that modification. We have to modify the grid. We have to modify the grid. Okay. So we have to go for this define tab, and here you have coordinate systems of grids. You can go here and go to this modify option, and here the positions of the grid lines are shown. Positions of the grid lines are shown. Okay, so A is at 0 location, so this is 0, 0, 0. A is at 0 location, B is at 2.5, C is at 5, 7.5, 10. So I'm reading these values here. A is 0, B is 2.5, C is 5, like that. On the other direction, so this is 0, 1 is in 0 position, 2 is 3, 3 is 6, 0, 3, 6, 9, 12. So those are the positions. So this should be 3. In that case, this should be 5.5. We can modify all these 4, 3, 5.5, 8, 10.5. That's also an option. Okay, if you go from the basics, that's an option. It should be 3. If this is 3, this should be 3 plus 2.5. Right? That's 5.5. This is 5.5 plus 2.5. So you can add 0.5 to all these positions. Okay. Or the other option is, here you have two options. go to the spacing, then the distance between first two grids is given here. The distance between second and third grid is given here, like that. So if we make modification here to be 3, the grid spacing between first and two is 3. Okay. Once again, if I switch back to normal thing, 3, 5.5, the 5.5, but the 0.5 is added. Okay, the 0.5 is added there. So if I press OK, we have drawn the grid. We have drawn the grid. So where are we now? We have defined units. We have defined initial geometry. That's grid only. We have defined the grid. Okay. Then we have to add structural elements. We have to add beams. We have to add columns, and we have to add slabs. Slab we'll discuss later. There's a different way that we add the loading on slab that we have to discuss in a separate forum. So we'll define here adding structural elements. There are 2 steps. We have to define structure. We have to define columns. We have to define beams, and we have to assign the defined beams to the locations that we need. Okay. So the first step, defining beams and defining columns. Define, you have a tab here for defining. Okay. So I'm using the SAP 2014 version because it's easier to, like for me, it's easier to use this. So if you have a newer version, the places that you have these things may be different. Right? The thing is, in the define tab, anyway, there's a place to define beams and slabs. Okay. Section properties, frames, tendons, cables. You know the difference of this, so I'm not going to discuss this. Beam is a frame section. Column is a frame section. Okay. Define tab. You have the section properties, frame sections. Right. You have to add something new. Here you have to select the material. If you are selecting steel, so we have, for the time being, we'll assume our project to be reinforced concrete because it covers a lot of stuff. It covers a lot of stuff. If you have steel, you have these flanges, the channel sections, the angles, everything you need is there. So if you select concrete, you have to give the shape. You have to give the shape. Typically, we have rectangular beams and columns. Okay. If you're designing a bridge, you may be able to select this precast option. If there are circular columns, you can go for this rectangular. So I'll do that again. Define section properties, frame sections, add new. And I have selected concrete here. Rectangular. Okay. Then we have to select the dimensions. We have to give the dimensions. Let's say we'll define columns first. Let's say 500 by 500. This is initially for iteration. You can change it later. There are rules of thumb. I'm not using any of them here. Okay, I'm not using any rule of thumb. Just I'm assuming the columns are about 500 by 500. This is a 5-story building. It may be larger. When you design reinforcement bars, if you get a lot of bars, you can increase the section, or if you feel that it's too large, you can decrease the section later. You just have to modify the section properties here. Okay, the reason that I gave this is just a name. This is just a name. Reason I gave this 500 by 500 is that we can figure it or we can identify it later, because otherwise column, when it says columns, we have to go to the section properties window to find out the dimensions. There may be several sizes of columns, several sizes of beams. So as a practice, most of the structural engineers adhere to the practice that when you define a section, we normally give the size with that. It's just a name. If you want, you can give columns on, like you can keep the name like this, no issue. But as a practice, keep it like this. Then you have to give the material. Here we have not defined the concrete that we need here. So we can press this plus mark. We can define the define tab as well, but we have to define a concrete here. Since we don't have the material that we need here, okay, we have to give the material. We have to tell the software that this column is made out of this particular material. Okay, so you can give a name here. Let's say 30 grade 30 concrete. Okay, concrete. That 30 is the strength for us to figure it out later. For us to differentiate later. There may be different grades of concrete that you may be using in this project. So for the places where we use grade 30 concrete, it's easier to identify if we give the 30 with the name. Material is concrete. Weight per unit volume, that is the density. Here normally we add 25 because it is reinforced concrete.
Yes.
Because reinforced, normally 24 is the density of concrete that you're taking. Okay. Since it is reinforced concrete, we normally add 25, 24, 25 is okay. Modulus of velocity. How do you find the modulus of velocity? How do you find the modulus of velocity? There's a formula 5.5 times. I'm pretty sure that you have learned. As I can remember, it's 22.5 into 10 to the power 6. Okay. Poisson's ratio of concrete is normally 0.2. Right? Coefficient of thermal expansion, we are not really interested in this. The strength. What is the value that you're going to enter here? 30,000. You can make the conversion. Newtons per millimeter square to kilonewtons per meter square. Okay. So the value that you have to enter here is 30,000, and we have to give the dimensions 0.5 and 0.5, and you have to select the material here. I'll do this again. Okay. So we have defined columns. Now we have to define beams. Okay. We have defined columns. Now we have to define beams. The only difference is the section size is different. Column is 500 by 500, beam is 500 by 600. That's not good practice as a structural engineer's point of view. Beam bigger than column is not a good practice, but that's a different case. For this purpose, I'm copying this. There's this option, add copy of property. Beam 500 by 600. So depth is 0.6. Why is it normally the depth is higher than width? That you know, right? That I don't need to. So we have defined these two sections. Okay, we have defined these two sections. Now we have to add those columns and beams here to these positions, right? We'll add columns first. So to add columns, okay, after defining, as I told you, the next step is assigning. Okay, we have to assign the frame sections that we have defined. Okay, that's one option. Or there are these options at the left hand side of the default window where we have the quick access. Here you can click on this and drew the frames and cables. The frames, okay, like the beams and columns. If you need to draw a slab, you can select one of these three options. I'm not going to go through each and every. You can select this is drawing from the scratch. You have to select 2 points. Here you select a point and it will be drawn. For example, the columns are in the vertical plane, so I have to select one of these two places, right? And in the let's see. So we have to add columns to these 5 places. One option is clicking on this and we have to select the one that you want to draw here. We're drawing columns, right? Click on this and click on that. The column is drawn. You click on the right click button. That column is not continued. You can keep on drawing columns. Then right click. This, and right click like that. Or you can select this option, quick draw, and click here. That's also an option. Then we can go to the other plane and keep drawing like this. Okay. Or else the other option is sorry, my escape key is not working properly. I can delete this. Since I have drawn this, I can copy it to all these other grids. Neither. I can copy what we have. We can select this. So I can select. I can copy it to these grids. Drawing from the scratch is also an option. Or I can copy. Okay. To copy, as I told you, the word that we're using is replicate. In SAP2000, it's replicate. In your edit tab, you have this replicate option where you can give the direction that you need copying, dx, dy. In x direction, what is the distance between two copied elements, dy, dz. So here we have 0, 0, 0 option, and this is our y direction. We have drawn the beam here, right? We have drawn the beam here. Then we need to copy it to this, and this. We have to copy it 4 times in the spacing of 3. Is this correct? No. Why? If I give it in dy to be 3, it copies in positive y direction. So we'll, if we press OK, this is wrong, but if we press OK, See, it has copied in positive y direction. It has copied in positive y direction. So what can we do to prevent that? Edit, replicate. This has to be -3. 4 times. Then all the columns are drawn. All the columns are drawn. Right? Beams also are like that. Beams are in this plane. We have to select beam like that. The beams are drawn. You don't need to copy or anything. You just have to select every place and it's automatically drawn. Okay. And there's a modification that we need to make. Here we don't have a column here, and these two beams we don't have. You don't have a column here, and these two beams you don't have. Here you don't have a column. Those modifications will have to be made manually later. So this beam we have to delete. This beam we have to delete. These two beams we have to delete. And this column. This column. And this column. And this column. Hope it's clear for you. So if I rotate this, right? So it's okay now. What you have here has been drawn here. Okay. So I think it's enough.